All right, cool. Okay, I mean, the reason I usually don't record these is because it's not really that structured. It's mostly for you guys. If you have questions on particular problems on the practice midterm. So again, the midterm itself is going to be very similar to the practice midterm. And then another hint I will give you guys is I encourage you to do all the questions you can do first, and then go back to the harder ones. Okay. So last midterm review session, we started from question 1 and we went down, I think, to question 14, 15 in the practice, 15 in the practice. Yeah, do you guys just want to start backwards with the practice midterm, or do you want? Okay. I can also give you guys like more. So the one thing I noticed about the practice midterm is doesn't have that much practice on the coding questions. So I did also try to think of a few coding questions that we can try if you guys want to do that.
Okay.
So what do you want to start with first? Any preference?
Personally, I'd like to start with the code. I'm not that great at code.
So most of the points on the exam are going to be from questions similar to the practice midterm.
Okay.
But there are going to be coding questions. I think there's 3 coding questions that I personally consider like challenging, I would say. Pseudocode. There's no
one pseudocode one.
Yeah, sure. So here's a good one that you should probably try to. What is a good one? Okay, here's a good one. So let's say you have. Oh, this marker is not going to work. Nobody has a marker. Right?
I don't write anything on paper. I have no pencil.
Yeah, no, same here. That's why.
I have accommodation, so I
Oh,
don't
okay.
have to. If I
We're
don't
about to,
want
okay,
to.
thank you. One of these. Thank you so much. I should buy some of these, I
If I
guess.
ever have to write notes, this is where the notes get.
Huh?
I said if I ever have to write notes, this is where the notes get.
Mine's bright
Oh.
red because I keep losing
Nice.
it.
Okay, so let's say I give you a binary tree. Okay, so somebody tell me, so what is the definition of a binary tree? Let's say it has numbers in it. Okay, so this is the problem set up. So everybody knows what a binary tree is, has 2 children, right? You should remember that, okay? So the problem, let's define a, there's something called a root to leaf path. That is going to be a path that goes from the root to a leaf. So 4, 3, -2 is a path. 4, 7, 10, 1 is a path, right? And the question is, given a binary tree, what is the path with the maximum multiplicative value? Okay, so let's define. So for every path, I can define a multiplicative value as multiply all the values along that path. So for this path, 4, 3, -2, its value is going to be 4 times 3 is 12 times -2 is -24, right? This path 4, 7, 10, 1, its value is going to be 280. Sure, 280. Okay. So the question is, given a tree, give me the value of the biggest path, not of the longest path. Give me the value of the path that has the largest multiplicative value.
It's 280.
Yeah, so for this tree, it's 280. Yes. So if I added like a 3 here, that would change it. But yes, I think for this tree, it's 280. So that might be the question. Let's say worth 10 points, and you want to write pseudocode for it.
She has a question.
Yeah.
My question is, do you ever count multiply the leaves inside of the tree, or is it only the outskirts of the tree?
It is. So again, a root to leaf path is a path that starts at the root and ends at a leaf. And then the value of that path is the product of all the nodes along the path. So there's one path here. There's another path here that goes 4 times 3 times 2. There's a path here that's 4 times 7 times 9. There's a path here. Yeah, there's a path here actually, because it ends with this node, that's 4 times 7 times 10. And then there's another path that goes all the way to the 1.
So which would you return if the path equal the same?
So that is why I specifically didn't ask for the path itself, because in that case, I would probably say return any path, but I just said return the maximum value. So if 2 paths have the same value, it's the same answer. Yeah, Leander, you wanna?
So since there's a negative in there, we have to keep that in mind as well for considering multiplication. So always going to be positive.
I'm trying to think if it matters. Sure. One way to try to make a problem easier is to like try to make it easier. Okay, let's say all the values are positive.
Because if it's negative, you can have very big negative numbers. That's ultimately small.
So let's say I simplified it. So I tell you, you have a binary tree, and all values are positive, aka strictly greater than 0.
Did you fix that then?
Yeah, I removed this.
You had a failure.
Children, it has two.
Huh?
Fix which? The children for 3 are the same.
But do you want to add the restriction that they're also all different?
Yeah, I'll assume that, maybe the inside operation will just fail. Just say, okay, maybe.
To be honest, I believe it does not matter, and it does not make it easier. Whether they're all distinct or all positive will not affect your solution. So yeah.
So
Sorry.
it seems like you basically just have to recursively go through every single path and compare. Like in the recursive case, you could have like a call to multiply everything on the left, and then after that, a call to multiply everything on the right, and compare it. And since it'll be recursive, it'll basically go through every single path.
Okay. So you're trying to think of a recursive solution to this. I think that's like very natural. So anytime you see trees, a very natural first approach is to try recursion. Obviously, a drawback of recursion is you build up your stack, but that's not like something that this quiz covers. So sure. So first we define our function, right? So let's call it max tree, and it takes in a tree t or whatever. And then for the pseudocode, normally what you do is you define you say, your inputs and your outputs. One thing for the midterm, you will get points for having a base case. So the way the grading is going to work is like usually having a correct answer is going to be just 1 point. But essentially, if you are like, they have the base case, that's like 1 point, right? They considered the recursive case. Even if it's wrong, it's like you considered, the recursive case. So that's like 1 point, right? And then I might talk about how I would grade this after, but yeah, so this is a tree. You're saying something about recursion. So you're thinking about something to do with the left, something to do with the right. Yeah, so
For the base case, couldn't you say as long as your tree isn't empty, and then as long as your tree has more than just the root node?
right. So usually for trees, I would say the simplest base case, like you mentioned, is to always consider is just like if t is null. Okay, this is actually a pretty good question, which is like, if I have no tree, what would you define the answer to this to be? You might come back to that because it kind of depends on how you want your multiplication to be. Yeah, do you have any?
You have for that one kind of have to do 2 different base cases. That one there will be zero at the end. But if you have nothing, you want to return 0. But if you at the end, you don't want to return 0, because that time whatever.
Right. Yeah. That is something good to think about. So normally I would say you might return 0 for this base case, but you are kind of thinking that like, if this is my base case and I get to the end, if the only thing I return is 0, then when I multiply that by anything else, it kind of becomes 0. So in a sense, I probably wouldn't take points off for this, but there are 2 cases, one where the tree is actually empty, but to make it easier, we would just consider like the very, very base case for non-existent tree, the answer is going to be 1. Yeah.
Is there actually a Zoom call? Because I really can't do this from people here in the staff.
Yes, there is. So there's, I guess the room is a little bit too small. So if you join the Zoom for our class, you can, like it's recording this and also my voice, because yeah, we've got too many people in this room right now. Sorry. Yeah, apologies for that. Okay, so we'll stick with this for now. What's the recursive case for this?
Maybe if the current node doesn't have any children, you just return the value that's at the node.
Okay, so I would consider that another base case, but sure, so that you could also check like if t dot left and t dot right, whatever, are null. So it has no children. Then you return, actually, this might be a better base case than this one. Sure, you return t dot value. Okay. Sure.
Maybe the actual recursive stuff. For each one, you kind of want to have two older variables to count up how many times you have. Because you have to get both the left and the right multiplication and then comparison. So
Yeah.
two variables first, and then continuing to go down the list
Yeah.
until it gets to the end. And multiply on top of each other so it gets there.
Yeah. So one thing that helps with recursion is you don't actually have to think about the entire problem, right? You have to just say, so one way to think about this problem is this part here is also a tree, right? This left child is also a tree by definition. So if I call myself, if I say max tree, like let's assume that I already have, like it already works, my solution is correct. If I call myself on t dot left and I save that to a variable, what is this variable going to tell me?
To tell you all of everything that you've multiplied up on the left side until you've reached a null, until the left side doesn't have any children.
Yeah. So for this example, for example, what would it return?
3 times 6.
It would return 6, right? Because it would say for this subtree, the maximum possible value of any path is 6, right? So this, in a sense, would be like the max of my left subtree, right? And then you can imagine you can do the exact same thing to call yourself on t dot right, right? So again, what would that return here?
70.
70, right? It would return 70, right? So again, because you're relying on recursion and you're kind of, let's assume this works, right? Because my trees are smaller in a sense. Then this is going to give you 6, this is going to give you 70. Now your question is, for this tree that starts at 4, what is the biggest value of any path?
280.
How do you know it's 280? How did you
have
so
more
given this answer, given this answer, and given this, how did you come up? How did you know it was 280?
you know you can leave that side alone because that side is bigger. It already says it's 70 and then you have 6. So 70 is greater than 6, so you already know to negate that side and you're going to the right, and then 4 multiplied by 70 is 280.
Yeah. So what I would say basically, I think what he did is he considered there's 2 cases. Either my path, I start at 4 and either I went to the left or I went to the right. If I went to the left, then the maximum possible path is going to be 4 times whatever the maximum possible path was for this tree, right? So one option is going to be, so I might just actually do it here. I might do times t dot value. So that would be, this would do 6 times 4. That would put 24 here. And then the other option is I go to the right. So that again, that would be times t dot value. So that would give me 4 times 70, which is 280. And then my answer is actually just the max of these 2. It's left. Right. Okay, this solution might get full credit almost. I don't know. At most, it would lose like 1 point or something. Why would it lose 1 point? I'm actually not too sure because I'm not sure. Actually, I
Probably
think
for
it'll be
that-
fine.
The first base case that we came up with, because it can
If
like
you
negate
include
itself a lot of the time.
If you include both base cases, is it fine?
Yeah, if you include more base cases, that's fine. You don't have, it doesn't have to be perfect, it doesn't have to be perfect. I think the only case I'm worried about is when, I think this works, but actually, I actually think this base case is better than this, because if you have actually, I think this should work. Yeah, it'll work, because it'll take care of negatives. But I guess we did also assume it's positive. So any questions on this solution or issues with it? Yeah.
So if we got an actual question like this, will we be provided the tree or we have to basically make our own?
You would probably be given an example tree, but again, the solution you're writing would not be for the tree you're given, but you for all the coding questions, I do provide a few examples. So if there was one that was a tree, I would say like, for example, in this tree, you know, the answer would be this because, you know, whatever reason it is given. Or if I give you an array, I would say like, you know, if you call your function on this array, the answer would be this because of whatever, similar to the homework assignments. But I think the key thing to keep in mind is just like, remember that for recursion, especially for trees, usually you do something with your left, you do something with your right, and you kind of assume that it works out, right? So now the other question you would get asked in addition to this is you would be asked about the running time of this algorithm. Okay. So who wants to provide an argument for what the running time is? This algorithm. Yeah, standard.
Would it be n log n? Because with the log part, splitting it up. Then doesn't actually n work without comparing the numbers.
I would say n log n is a good guess. Log n is also a good guess. Yeah. What other do you guys want to guess?
I said log.
You think log
I just
n?
thought log it.
Okay.
Is it a function of the height as well?
Wouldn't
Yeah,
it be?
I hear
So
O of
wouldn't it
n.
just be n?
N was one, I was thinking N two.
Okay. Well, okay, you guys have to pick one of these. You can't put all three on the exam.
I would go with
So
n.
do we want to take a vote or what do you guys want to go? Or do you guys want to argue? Who? Huh?
Vote.
What?
Vote.
Vote? Vote.
Vote.
Oh, vote. Do you want to vote? Would you each like to discuss? Who wants to like, who believes that it's n log n? Is there at least one person that is like, I actually do think that it's n log n, and this is my reasoning? You
I
thought
do
maybe
not.
at first, but now you're convinced it's something else? Okay, so n log n doesn't get any votes. Somebody mentioned log n. Okay, do you want to provide a reasoning or like what your thought process is for why it might be log n?
I can't know thought process. It just seems like that's
Seems right. Okay, so you know it has a tree in it, so like seems right. Okay. So any other arguments in favor of log n? Okay, seems to split work. The split work in halves. Okay. Any other arguments in favor of log n? Okay.
I was
Oh.
thinking like it was log n because like we are comparing, but we're not comparing like everything. In a sense, like we're comparing like two numbers at the end. Is what I was kind of thinking instead of like. all of
Okay,
it.
so that's Isaiah's argument, comparing two numbers at the end, not everything. Who wants to argue for n? Serena?
Well, for our solution at minimum, we're going to every single node and comparing every single node. So I don't think it's any way it could be smaller than n.
Okay, so the argument is that at minimum, with this solution, we have to go look at every single node.
Mhm.
So in order to get this 70, at minimum, we have to do, we have to look at 1, 10, and 7 in a sense. But also, we did also look at 9 because we didn't know, right, from this left child, we looked at the 9, we got 9 here. And then from here, we got 10. And we were like, oh, we need to compare these two times 7 and see which one's bigger in order to get this answer, right? So there is an argument that, okay, so you guys are already like, that's actually a pretty good argument. So you would say this algorithm is at least n. So that already tells you it can't be log n. Okay.
Is
Yeah.
it n squared?
So isn't it doing multiple things at the same time though? That makes it so split like faster.
Why do you say it's doing multiple things at the same time?
Because
Or-
when it's with like we're going with different person, so like that, you'll just get login is doing this part and this part and then combining them. Instead of just doing this part and then doing this part.
Yeah. you probably want to look at the master theorem when you're thinking about it that way, but it is looking at every element at least once. So it is at minimum n. The reason you might get anything that's less than n, for example, log n, is when you can throw away half of your problem. So binary search, or even when you do search on a tree, like a binary search tree, that's because you actually never look at this half of the nodes. You like end up looking at just the left side or just the right side. Because it is true, like we are actually not doing work like in parallel. At the end of the day, this actually goes down and looks at every single node and then builds it up. Okay, well, so out of the 3 guesses you guys came up with this, that is the correct answer. It is theta of n. It is actually theta of n. So it is not slower, it is not faster. And the argument is you look at every node at least once. And other than looking at nodes, the only other thing you're doing is taking the maximum of 2 numbers. So for each node, you take the maximum of 2 numbers, which is constant. You can also use the master theorem to calculate this, right? So you could say T of n. So when my tree is of size n, what I do is I call myself twice. Well, yeah, I guess this is a little bit harder to do. So yeah, it's actually a little, it's master theorem is not going to directly apply. You do call yourself twice. You can pretend you put n divided by 2 here. This is only true if the tree is balanced. But what is true is that you call yourself on 2 separate parts of the tree. So like whatever is in here and whatever is in here, they add up to the whole tree in a sense, except for one. That is actually what's true. So for this specific problem, you actually can't use master theorem because you would say like, oh, this, this is like A and B. And then you would have where A plus B equals n minus 1, and like they're disjoints, so there's no overlap. You're not like redoing work. If you know that, you can kind of hack it together and you can say like, well, it's kind of n divided by 2. Anyway, and then what you do is you do constant work at each step because you just take the max. So because you're doing the constant work, this recurrence relation is actually very similar to merge sort, except in merge sort, you do linear work to put the stuff together. And that's where you get the n log n, where because you're doing constant work here, if you look up the master theorem, actually this ends up being O n. But I think the argument of just you visit each node once, essentially, through all your calls. And each time you visit a node, you're taking a max of 2, 3 numbers, right? Therefore, the running time is O of n is a very good and valid. So that would be probably one of the more challenging problems, I would say, on the test. Okay. And that would be the extent of it. It would be like, here's a problem, give me some pseudocode, and then give me a running time. Now, for this specific problem, the easiest solution, I think, is this solution. There are other solutions you can consider. For example, what is a more brute force approach to do this? I actually think it's harder to implement. Yeah.
Oh, you meant the binary tree.
Yeah, for this problem, like this solution is actually the best you can do.
I thought you meant
Yeah. Do you have an algorithm in mind that has like worse runtime?
no, I meant finding the runtime. I thought was just actually going through it.
Yeah.
One thing you can do is keep track of every single path. You can have every single one and then find the biggest one.
Yeah. So that is also like, that would be like a more brute force, but actually to implement that solution, I think it's a little bit more work because somehow you need to like, so the way I would do it is I would define a vector of 0s and 1s where each number tells me whether I went left or right. And then basically you try all possible 0, 1 combinations. And for each one, you then go and multiply it to see how many there are. There's actually not that many because if you consider like the vector, if this is a balanced tree, the vector will be, there'll be at most 2 to the log base 2 of n of them. So there's at most n of them. And then computing how big the multiplication is will take at most log n, because if the tree is balanced, the height of the tree is at most log n. So for each path, it'll be at most log n. So even that algorithm is n log n. But again, the pseudocode or even coding that one up, I would say is like a little harder. But there are other algorithms. So let's try another question. Does anybody have questions on this one?
No,
So
I
this
just
would be-
wanted to take
yeah.
a picture of it.
Oh, yeah,
just
yeah.
in case.
Sure, please. And, oh, sorry. I don't know. There are folks on Zoom. Hey, Hassan, hopefully it's a little hard for them to see, but you guys are taking pictures. If one of you can either email them to me, or maybe we just make a post on Piazza and be like, here are the pictures of the stuff we did in the midterm review. That'd be great. Just share it with the other students. Yeah, any other questions on this problem? You may see something very similar to this, but not the same, but surprisingly similar to this. Okay. Let's try another one where there's actually, and this is like a pretty decent interview question, I think, for like sophomore-ish. Yeah, that's why it's hard, because in an interview you have like 30 minutes to do this. On the test, you'll have less. So you have to be very, you guys should be diligent with your time, right? Like just, you don't have to get everything right. You just have to put stuff down, put your first thoughts. Even if your running time is not correct, if you provide a reasonable explanation, that's probably worth some points, right? Yeah.
Do you still get points, like if you kind of explain why you feel that?
Yeah, in general, so we did, so Chi and I got together yesterday, so midterm's finished, so we got together yesterday to come up with a rubric. Yeah, like in general, I am trying to encourage you guys to just put your thoughts down and what you believe. So usually actually being correct, and this is also the same for interviews. In general, being correct is not like the thing that we are looking for. It is more like, did you have like was there a little bit of thought process? So I would say for like the answers you guys gave me, like for O of n, those were good. For both log n and n log n, I think when you guys were giving the explanation, I was like, well, kind of reminds me of this, kind of reminds me of this. That's like not it's like okay, but it's not like a very rigorous explanation. You're just mostly saying like, well, you know, I saw another algorithm where we split things in half and that was log n, right? Yeah. So another coding problem, and again, this one might be good to jot down and kind of like understand, to prepare you guys for the midterm. You will not see these exact problems. There's only so many questions you can ask. I was actually talking to Chi and she's like, yeah, you know, all the questions are like the same at the end of the day. But, you guys might have seen a version of this, but let's talk about an array now, for example. So it's gonna be very similar to that question we asked, but now you don't have a tree. So the solutions might actually be very different. So it's going to be an array of integers. Let's say 4, 2, -1, 3, 11. And we are going to define a contiguous subarray as an array A from I to J that includes all the elements from AI to AJ inclusive. Does that definition make sense of a contiguous subarray?
No.
No.
I'll tell you right now, no. Not to me.
That includes all elements. Okay, that's very interesting because how would I contiguous subarray as an array that includes all elements between AI to AJ? Does that help at all?
No.
Are you basically, if at the end of the day, are we just making one array that contains all elements that are within AI and all elements that are within AJ?
Includes all elements from, actually, this might be better, from I to J.
I'm thinking,
Can you define the
is
first
this
one?
like all elements, you have to find a subarray of this array that includes all the numbers that are within that range? Like
Sort of, yeah, but
AI
Or are you
array
picking
is
all the ones that
You're-
are the same within the two arrays?
no. But yeah, so contiguous, yeah, so contiguous, okay, so subarray, first of all, subarray is a subset of the array, right? That's what subarray means, right? So for example, 4, 3, 11, this is a subarray, okay? Because it has 4, 3, and 11, and these elements exist in the original array, and now they exist in this, okay? So that's a subarray, which I was hoping you guys knew what that was, but that's okay. The condition that it is contiguous just means that it has to be a subarray where all the elements appear next to each other in the original array. So for example, 4, -1, 3. This is a subarray, but it is not contiguous because it has 4, and then it skips the 2, -1, -2. However, 4, 2, this is a contiguous subarray because it's just these two that are next to each other. You know,
So make an array.
2, -1, 3. This is also contiguous. Okay, so the problem is not make the contiguous subarray. The problem is this is just defining what a contiguous subarray is. Yeah.
So then for the 4-2, like the I would be 0, the J would be 1.
Yes. Yeah. Here would be I would be 0, J would be 1, and that defines this subarray. Here I would be 1 and J would be 3. So that's 0, 1, 2, 3. And that defines this subarray, right? So just saying take all the elements that are between the index I and the index J. Yeah.
Are I and J like given to us, like our search for, or we have to find it? We have to pick it up as well.
This one is just, I haven't even asked the question yet. This is just defining the problem statement. Yeah. So I might need to tweak the question there is a question about contiguous subarrays in the midterm. So I'll need to tweak it a little bit to maybe give you, I do give you examples, but I guess it might not be obvious to you guys what that is. The actual question is, similar to the tree question, let's define the value of any subarray as the product of all the elements in that subarray, right? The question is, for an array A, what is the maximum value of any contiguous subarray? So for example, like we said, this is not a contiguous subarray, so we would not consider that one. But the value of this would be 8. The value of this would be -6.
So the maximum value that we would be able to get from here would just be 33 because it's the last 2.
Yeah, the maximum would be, yes.
This.
So the answer would be 33. Yes.
So are we still going to account for the fact that that has a negative number in it? Because if you do that, you can basically say anything that's linked to that negative number will not get you a maximum.
That's not necessarily true, because if I have another negative number, then actually this is the biggest, right? Because the two negatives cancel.
What if you also go to, because you can include the whole thing?
Oh, yeah,
Would.
yes. In this case, you would actually go all the way to 4 too. Yes.
So I and J are not gonna be given, because then wouldn't the answer just pretty much be the whole array every time?
Yeah, I and J are not given. I and J, this is just defining what a contiguous subarray is. And now it's saying out of all possible contiguous subarrays for this array, I want you to find the subarray that I want you to find the value that is the biggest for all the possible subarrays.
So it has to include positive and negative numbers. 'Cause that's
Isn't the
only
answer
way
just
such
J
a-
minus 1, or
the
is it?
values are different.
Well, in this example, it's not true that you, actually, yes, in this example, I think the entire array is the answer almost always. But
Like a subarray itself?
Can a whole array be called a subarray?
yes, the whole array can be called a subarray. Yeah.
It's the
Oh my
same
God,
as
there's
like-
so many things that
If you think of it like statistics, it's the same as a set and a subset.
but I would say, again, you may have a question similar to this, but I would encourage you first, so you guys are looking at a lot of like patterns, but I would encourage you to try to think of like, pretend I don't know anything about the array. What is like a brute force way to do this?
You'd multiply each of them next to each other. Because you go from like, let's say you go from all the way to the left, you go, okay, you have 4, and then you have 4 and 2, and then you have 4, 2, -1, and then you have 4, 2, -1, 3, 4, 2, -1, 3, 11. So you basically just be like doing that, basically adding an element on each time to see if it's going to be bigger than the previous one.
I think you have the right idea. you might be going towards the right solution
Sounds like-
for the brute force. But let's, you know, going back to the tree, we said, oh, there's one solution where like, let's consider all possible paths, right? So almost all brute force solutions are in that definition of like, let's consider all possible subarrays, right? That. So. All right, any other suggestions? All right, maybe you guys take it from here, like, yeah.
If you.
Do people understand the question?
No.
Is it- No, okay. Does somebody who does understand the question want to explain the question for the rest of the?
I think the question, my thinking, like when I was bringing in the negative, numbers, like if all the numbers are greater than 0, then the entire array will always be the answer. It would, so I'm assuming that there always has to be negative, either a number equal to or less than 0.
So that is actually a good point for this one. I think there might be a very interesting, okay, well, actually for all this, yes. So you could start with that. You could say, how long does it take to check if an array has a negative number in it? You have to check every element, so it's all that, right? So you could do that. You could say like, okay, my algorithm is first, you know, check if any negatives, right? Well, first of all, the other question to ask you guys is like, forget the array. What is the fastest possible this algorithm could possibly be? Like, is there any way I can give you the right answer without looking at every element? At least once?
You have to search through the whole.
You do have to search. it.
Well, it's not even search. It's like I have to
You just have
look
to
at what
get-
the
yeah.
number
Yeah.
is, right, at minimum. So the fastest you could possibly hope to solve this problem is O of n. So if you have any ideas that are going to take O of n, it's like, sure, go ahead and try it, because like it's not actually going to slow you down, right? It's just like, sure. So check if any negatives. That was a suggestion from Trinity. So let's negatives in the array. So what does that pseudocode look like? I guess just again, in the exam, you would want to write like partial code. To try to
Just
get
an
credit.
enhanced for loop that runs through everything and checks if it's less than 0.
Right. For I equals 0 to, let's say, n-1, and let's say, you know, like somewhere else you wrote n equals length of a or whatever, then if, you know,
A at I is less than 0.
I is
Less than 0.
Less than 0.
less than 0, then you have maybe like a Boolean, which is like, you know, found.
Would we also have to check for 0 values, or would that just not matter?
So you can do less than or equal to 0,
Okay.
but if you hit a 0 base, it's kind of the same thing. You hit a 0, you can't go 4, 2, -1, 3, 11, 0. That you just take off the 0. So everything before that 0, you basically have to think of as its own chunk.
Let's stick with the first idea. So just checking to see if they're negative. So if I do find a negative, I say found, you know, negative equals true. Already writing this probably going to get you some partial credit, right? Even though, to tell you guys the truth, this does not get you that much closer to the actual solution, but it, you know, it does do something, which is you notice that if there are no negative numbers, then, you know, if not found negative, you actually know the answer, which is just, you know, return. Again, you would write like a, you know, 0 times a 1 ... times a n-1. And again, for n-1, again, like for these little details, I don't want you guys to worry about them. If you put n, that's going to be fine. Again, whatever pseudocode you write, as long as it's clear what you're doing, then it's fine to write it. Okay, so that is the first idea. All right, so now, so yes, if I gave you this problem and I said there are no negative numbers, this solution is correct. There are no, if I told you that your inputs are only positive numbers.
Including the negative part above, or just?
This whole thing would be a correct solution. And the running time would be a theta of n, yeah, O of n, theta of n. Both of those are fine. Theta of n is more precise. Now, what would, okay, so again, the original question did not have that restriction. So there can be negative numbers.
So could you just like start like, because it said it has to be a contiguous partition, could you start from say like 4 and then multiply basically like, I'm envisioning like some kind of like
Yeah.
triangle right here. So it's like you're starting this from here to there and then from here to there, just multiplying and then kind of finding the max each time.
Yeah, so I think both you and Jonathan are getting to what I want you guys to think of, which is, what is the brute force solution here? Okay, how would you actually solve it if you didn't know what the numbers were in the array to start with?
I can think of a
Yeah.
formal runtime solution.
Sure. What do you?
No.
Yeah, I was thinking.
Yeah, the only, the worst. the worst
Nested for loops. Okay, yeah. So
Yeah,
again,
just
this would
running through
actually.
step by- Just running through like every single possibility and then comparing
Yeah.
them, but that's the worst possible runtime you could get.
Again, you would probably get
Yeah.
most of the points in your exam, and that is a good place to start, because as you understand the problem more, it might help you improve the
You can
runtime.
simplify.
So again, I don't want to encourage, like, you guys should not be trying to jump to like the most optimal solution immediately. You wanna think for it a little bit and say, like, maybe like you notice this thing about the negatives, you could write this code, get some points there. And then once you're like trying to figure out the negative thing, if you're taking a long time, you're like, I can't really see what's a better solution. Then after you write this code, don't erase it, either cross it out or leave it there. And then just below it, you would write the brute force solution,
So
right?
then like,
So yeah, let's write, sorry, Vincent, you had a question. I am taking points off for not being the optimal solution, but not that many. Okay, it's not like gonna be the end. Like, I seriously doubt anyone in the class is gonna get a perfect score in the exam. So I hope that is like.
that's not a good thing to tell us, because then we all panic.
Oh, okay. I mean, no. Okay. Wait. No, I'm just. But I will tell you that if you do your best, you will pass the class.
Okay, appreciate that.
Is that? I don't know. Wait.
Anxiety.
Okay. There are also bonus points on the exam, a few of them which are pretty free. So if you've done your homework and stuff, that actually gives you like 3 bonus points, which is worth more. So yeah, I'll tell you. For most of the questions, getting for these types of questions, they're worth, I think, 10 points. Getting the optimal solution is the 3 final points. If you get a terrible, bad solution, but it works and you give me the right running time for it, that gets you 7 points out of the 10. And then there are bonus questions such as, did you enjoy this exam, that give you 1 or 2 points back. So there.
If we say no, is we still get the points?
No. Yeah, you'll still get the points. But again, I will let you guys know, like, the exam is not, I would not call it easy. And I guess I would love to talk to anyone in the class that gets all the answers right. 1, because I would think maybe you saw the exam before, but 2, also because you should not be taking this class. I feel like you should be interviewing constantly to get really good jobs.
Boom.
If somebody gets a perfect score, I will like give everybody in the class like a bonus 5 points or something.
Yeah, no, definitely.
Yeah, but again, don't freak out, because the other thing is the exam is designed such that for these questions that are harder, like I hope the way I designed it that like more than 70% of the points will be kind of like straightforward to be had if you like studied and kind of follow along the class. And then the rest of the points are the ones that are like, hey, let me challenge you a little bit and see if because technically you guys do know everything to solve this problem. You just maybe haven't seen it before. You don't know all the tricks, right? But yeah.
How much space will we have to write out the zero code?
Can
Like, for
we use
example, if you
extra
have all
paper?
that out and then X it out, then how much space?
I'll probably bring along like extra pieces of paper if you need extra paper. And then usually for these problems, you're given around like half the page there. So when you look at the exam, if you see a problem that has a box in it, that's usually I want you to write pseudocode. So you might want to skip those first and then come back to them later.
And can we assume whenever you say the value of something, you're talking about multiplying? Like multiplying the number inside?
No, there are other ways to define value, which may be presented in the exam, and they will be defined as part of the question.
For this example, are we assuming multiplication?
For this example, I told you the value is, I guess I said it out loud, I didn't write it, but yes, the value is a multiplication. But regardless, let's write the pseudocode for the brute force. So somebody mentioned trying all of them out. So somebody mentioned nested for loops. Who wants to? Yes.
So you have one for loop that starts at the first value and then just runs until the end.
Oh, thank you. Sorry, I am like, I will buy you some more of these. I'm sorry.
No,
Just
like-
remind me. When I say remind me, I mean send me an email. Okay. For I equals 0 to, let's say, n minus 1. Okay, so this is a for loop going over all the starting points. And
Then
then,
you have, and
yeah, I
So
say it.
what happens when you go to 2 and you have to include like 4?
so,
So, how are you asking that question? I don't understand how you're asking that, for me to understand.
oh, yeah, no, I get that. Well, I guess have the brute force solution, but it's not.
So, like, are you saying what happens
Well,
when we run
who wants
into a
to give me the
negative
next
number?
step of the,
Yeah.
or, yeah, you probably have the right idea. What do
I
you?
just really have what's stupid on this.
Oh,
I just. Also, if we submit an answer that's basically dependencies, is that considered pseudocode or should we turn it into?
Um,
your styles?
you want to try this style, but
If there's both
again,
on there, is it fine?
Huh?
If there's both on there, is that fine?
yeah, like you want to try to
Okay.
be, so the thing with this style is just, like, it is very precise,
Yeah,
right? So
I
when
can-
I say like, from 0 to n minus 1, is like I actually define, if you say, from the start to the end, it's
Yeah.
like, in this context, I probably know what you mean,
Yeah.
right? But there may be other contexts where you say start to end and like, you really mean, from 0 to something or whatever. Like, for example, the next for loop here would probably be for j equals I to n minus 1.
Yeah.
If you said from start to end, and then here you also happen to say from start to end,
Yeah.
you probably mean like this is what you
Yeah.
mean, but it's not.
See, I
Clear,
can do that
yeah.
translation on paper, but like, that'll also be this too, because this is how my brain thinks, and then I turn it into that. Is that fine?
Yeah, I would,
Just,
so I would encourage you, again, like you guys, the exam is probably long, so I would encourage you guys to write down your initial thoughts, get as far as you're comfortable, and then move on, because there are going to be easier questions. There are going to be questions you will read and be like, okay, I know this is easy, and it's going to be like 2-3 points, right? And you're going to be like, great. And then there are going to be questions like these, where if you do the brute force, you'll get 7 out of 10 points. And then the rest of the points are like, you are going to have to think a lot more and be like more clever and et cetera. And you might not get them, right? It might take you 20 minutes to like figure it out. And that's like 20 minutes you could have used getting 3-4 points in other questions, okay? So especially for this exam, that's what I would suggest. So brute force so far. So this is going, so why, this is considering all possible subarrays, right?
Just, yeah,
Wow.
well, most of them.
So because now I have an I and I have a J, right? Then that means that I can compute what the value is of that I and J, right? So I can
You
say,
also technically run it backwards.
yeah, you could do a lot
You
to
do it forward-
optimize
you do it
this, but
forward and do it backwards, but that's still a horrible answer, it just technically works.
I think actually that gets you to the right idea. Like this answer is gonna end up being O of n cubed. There is a pretty easy way to make it O of n squared, which is you're actually getting to that second approach. And the solution, there will be more hints for similar problems to get you further along to even better solutions.
My second.
But you can imagine this is from k equals I to j, right? Then you can say, really what you want to do is you would say value equals 1, and then here you would do value times
Which
equals
version is this?
k of k.
Why would we do that? Why wouldn't we do?
Wait, why do you need the secondary for?
Yeah, you actually don't.
Not.
Do you guys want me to jump to the n squared already?
Third?
Or
Yeah, because my
Okay.
method
In
doesn't
our
work.
base case, like, shouldn't we check if there's more than one negative number too? Like if there's 2 negative numbers, isn't it just like?
you could also check that, but it will not help you. But it is something like as you're figuring out the problem, these are things you might think to check. Okay, so what do you guys want me to write? Not this?
No, leave that.
Oh, leave that, okay. And then you just want me to do value equals 1 here?
Yeah.
And
And then
then,
from there, just go like value times AI.
right, equals
Well, A,
value times
J, J.
AJ.
And then you
Okay.
would compare like whatever
Got it.
your current highest value is to your current to the
Got it.
value
If
there.
value, right, is bigger, so I need a max value.
And your start max value would probably just be like the first element in the array.
Sure.
Just to give a
It
baseline.
turns out in this case that you can use max value equal to 0 because I can define the empty subset of an array to have multiplication.
My brain doesn't like that.
Oh yeah, actually, yeah. Are you guys still following along for this a little bit?
We're trying to.
Oh, you guys are trying to figure it out.
Are you doing n squared or n cubed?
N squared. They didn't like my n cubed version.
Can you explain what this is right now? Like-
Yes. So this should be the solution that I think everyone here should be able to come up with. It does not require any tricks or anything special about the array. It is just saying, the question is asking, there are these possible subarrays defined by two numbers, I and j. And it's asking, out of all the possible subarrays defined by I and j, which one can you take the elements inside and multiply for it to be the biggest value, right? Not which one, actually, what is the value of the biggest one, right? So a brute force approach to that would be, well, let me define I from 0 to n minus 1. So let me consider all possible starting points of subarrays. Let me define j from I to n minus 1 or I plus 1 or whatever you want to do for all possible endpoints, right? So then by these two for loops, inside, I am actually implicitly considering all possible subarrays,
And
right?
then
Then it's like, well, for each subarray, I want to compute its value, which is all the numbers inside of it multiplied, right? That is my n cubed solution, because instead of doing this, what I would have done is I would have put another for loop and then just multiplied all the numbers inside. Now, Trinity and Sloan both noticed you don't actually have to do that. But I would say that is actually like an insight that you had into the problem, which is I can reuse, because what you're doing is you're reusing your multiplication from earlier every time you move the j up, right? And that is how you go from n cubed to n squared, by having that insight, which is like, oh, I can actually do this, right? So the n cubed is the one that I think anyone should be able to come up with, just in the sense of like, let me try all of them and then multiply them together. That's more of like, can I write the code rather than did I think of something insightful or clever about this problem, right? And that solution would give you 7 out of 10 points if you wrote it down and you told me the running time was n cubed, right? But yeah, so here, so to finish this up, we would actually start max value at 0. Let's if value is greater than max value, then
max equals value.
max value equals value.
If you do it like that, then do you not need to do it like this?
And then at the end, you would say, then I return whatever max value is. Right?
Wait, so then that
Is that this, or yeah, question?
This time.
Oh yeah, this is multiplication, sorry. And that's just the way the problem is defined. You can imagine other possible associative operators that can be used.
That doesn't work.
It doesn't work.
I can't explain why it doesn't work. I'm staring at it. I think value set wrong.
Value.
But I don't
This is
know.
different than how we would have regularly wrote it. We would have wrote it like I equals 0, value equals a of I, and then for j equals I plus 1 to n minus 1, but they do the same thing, but that's how I think we wrote it.
Okay.
Wait,
Is that?
So that I stays at 4 and then j starts at 2. Well, like we're looking at that.
But then we can't do it. Continue.
Well, this part is the one that makes it contiguous, right? Because you're, for a fixed I, basically what this is doing is you're starting at I, and then you're saying, what is 4 times 2? Okay, that's 8. What is 4 times 2 times -1?
Except it's not doing that. Is it? Or because my brain actually shows that it stops after 4, 2 and then moves on to 2. It goes
because j goes from I plus 1 to
Yeah.
n minus 1. So j keeps going forward. And so value, yeah, so
okay,
this
yeah,
one,
you're
yeah,
right.
so value starts at 4, right? Then on the first iteration of this for loop,
Okay,
We
you're
do
right.
value times AJ, which is 4 times 2. So we'll do 4 times 2, that gives us 8. Then on the next iteration of this for loop, because we haven't finished this one, J moves up to -1. So then it'll do 4 times 2 times -1. And this is what I mean by you're reusing your answer from before.
So then in that case, shouldn't we put a else break statement in there when it hits the -1? Because then it'll get -8, it'll realize it's not as big as the max value, and then it doesn't need to run everything else. Doesn't change anything, but still.
It could, because actually the answer for this one is it needs to go all the way to the -2 to then actually
Oh.
flip the negative back to positive.
Oh, okay.
Right. Yes, and again, like I encourage you guys to think of like, oh, can I break this? Can I shortcut it? But try to focus first on like this solution works because it tries everything basically. And for all of them, it computes the value and then it returns the maximum it finds. Right. So that is a good starting point. And the running time for this is n squared. This one's n squared. Yeah, I wanted to do the n cubed, but you guys didn't want me to do that. It says O n squared. I will say O n squared is not great.
I have a question.
Yeah.
So like, assuming there are no negatives, like if you check for negatives like we did, I was just kind of thinking out loud, and I saw like if you multiply, like if you split the array in half, you multiply the left side and the right side, and if you take the absolute value of those two numbers, if there's a negative, I don't know. Then you know, like,
So there is like a lot of clever things you can do with this problem, I'm realizing, because you can actually like you can count how many negatives there are, and if there's a positive number of negatives, then they cancel out.
Yeah.
So you immediately know the answer is the entire array.
But if that
You
ends
only-
up being pointless, doesn't it just add to the
That was my
runtime?
immediate thought process, but if we're gonna have to go through the array just to find the negative and the quickest we can get it is O n, then we might as well just do it another way.
No, but going through the array to find the negatives is O of n, right?
Right.
But then
So-
you still have to find the longest version, so it doesn't.
So it's-
But here's the thing actually that I just realized, which is if, like, so there's two cases, right? You have an even number of negative numbers, in which case you know the answer, and that is O of n. If you have an odd number of negative numbers, then yeah,
Wouldn't you just?
So
does
that's
that
the way
help
you're
you?
right.
Like, you know, one of those negatives
Wouldn't you know,
essentially
like,
splits
wouldn't you
the
just do the-
array
Yeah,
into
the biggest.
So it
one, the
helps,
biggest
but
and
it
then the other biggest.
It helps, but it doesn't decrease the runtime.
Yeah. I don't think-
You have the exact same
It's not
problem.
the
either. So
normal
if you
one.
do it and you're somehow doing the multiplication at the same time, it helps. Otherwise, it doesn't help.
Isn't the
I don't know.
separate, isn't it like O of n squared plus n?
Yeah, that would be O of n plus O of
So
n
it
squared.
doesn't matter whether you have that code or not.
Yeah, so it's okay to keep this code. I will tell you guys this. So for this problem on the exam, because we have covered divide and conquer, there is a solution that uses divide and conquer that you will likely get hints towards in the exams. So you don't need to come up. So anytime I'm like, oh, this requires a little bit of cleverness, usually I'm like, here's a hint. That solution has n log n running time. There is a solution also for this problem that uses dynamic programming, which we have not covered, that is O of n. It's actually a linear time. So for this specific problem, there is a linear time solution actually. That actually does not rely on the negative numbers at all, surprisingly, but that is like an interesting tidbit there. Yeah.
So, for example, for this question, what would be expected runtime? Like if you want to get the full credit, what would it have to be?
I would probably encourage you guys for the n log n. And then if I asked you for a faster one, that might be like a bonus point.
Okay, can we go over that in this
Right.
example?
Yeah.
Can you actually tell us what, like, how many points this version would lose first?
So this version would probably get 7 out of 10.
Okay.
We
I
already
can
take
do that.
pictures of this one.
Yeah, okay,
If
so-
you like,
Wait.
if you did the brute force and then you told me the running time is either O n cubed or O n squared, and you provided a reasonable explanation for that, AKA I have 2 nested loops,
Look, I
then
know my natural limitations. This is it. I think it open.
Or to get less than what's the worst.
I'd probably give it similar-ish amounts because they're very, very similar solutions. Yeah.
Now I'm curious about what it looks like. Can you show us it?
Can we do the n log n?
Wait.
No, this is n
Yeah,
squared.
we can do the n log n.
I hate.
Oh, did you guys take a picture? I'm sorry. Oh,
Yes, I didn't have a
okay.
picture. It's in the group me.
Thank you, thank you. There's a group me. I'm not on the group me.
You're not supposed to be.
Okay.
You're like, you'll
That's
figure it
fine.
out.
You know, I have my own groups and you guys aren't in them. I'm kidding. I'm kidding.
Are they all professors?
No,
They're all
I'm
other
actually
professors.
not part of, actually, even the professors don't have me in their groups. But anyway,
Ow.
it's fine. It's fine. Okay, so this is like, I might say something like this, which is anytime you have a divide and conquer with an array, you should consider splitting the array in half. So you might say, okay, well, there's three possibilities basically, right? Either the maximum subarray is on the left side, or it's on the right side, or it crosses the middle. Okay, so if I wanted to do this, I would say, okay, solution, given A, right? So first of all, you should always remember there's some base case. So we're going to come back. Well, actually,
As long as your array isn't empty,
n len equals A. What is my base case?
as long as your array isn't empty.
So divide and conquer almost always uses recursion, right? So what is my base case? What is the simplest answer to this problem?
Your array is either empty or has one
Right.
element.
So, yep, if n is empty, then we are going to define the answer for an empty array to be 1.
Mhm.
Whatever you define, I won't take points off for you, as long as it kind of works.
And then
I'm trying to-
couldn't you have
Thanks.
the second base case as if of
Yeah.
if
If n
your
is
array
1,
only has one, and it's just equal to
then-
the value of that.
I would actually say
Unless
that
it's
if the
less than
value is
0.
negative, the answer for this is also 1. Or
Because negative one times itself is one.
yeah, sure. And I wouldn't take off points. It doesn't really matter. Let's go with A0. Sure. 2 base cases. Okay. All right. So this would probably give you, some points just having these cases. What is the recursive, given what I said here about it's either on the left or the right or across the middle, what would you guys want to write next? Yeah.
So have we like multiplied the whole array to verify like if that's like possible?
Have we multiplied the whole array to see if it's a positive number?
I don't think we need to look
we-
at negative.
We did, so somebody did suggest that as a possible starting point, which is essentially checking to see if there are an odd number of negative numbers. You could do that, yeah.
Yeah, because, we're just like, you're saying, we could split the array.
Yeah. Hey, guys. Yeah, it's kind of hard, I think, for folks to see, but we will post pictures of what we're writing on the board, thanks to Sloan, who is my. And
I also wrote everything in like a PDF form.
that's
You
awesome.
are awesome.
Okay, I really wanted to ask for like volunteers in lecture to take notes.
Oh, hell.
Dude, does anybody already like take pretty good notes and you're like,
My notes are not helpful to anyone but myself. I wish that was a joke, but no.
This is a little bit, I guess, more straightforward to write down.
Yeah.
Like, when I take notes myself, it's like personally what I feel I need to know, so like.
Notes are get really
I think-
personalized.
It does-
I
It's
think
kind
in
of
your
hard.
case, I think I have a good.
there's extra credit.
I
have a
agree with
good,
that. I'll
uh,
try.
Uh,
a
I'll
good
take pictures
example
of the
something
boards
you
and
can
upload
do.
that.
Yeah.
You
But, like, I
already
can't do shit
have,
else.
you already post all of your slides.
Yeah.
And you post all of your slides on
I
a
feel
Google.
like I need to.
Yeah.
So as you edit on the board,
yeah,
Have someone
there's a
take photo
way
of that.
for like, the boards are digitized, so you can use like the little pens that they have up there and make those same edits, but you're making those edits in
No,
your
our
document.
classroom doesn't have
So
digitized
from there,
boards.
they should.
No, it doesn't. It's a PowerPoint onto a normal whiteboard.
That's trash.
Right?
So most of the.
all right,
time-
let's bring
Yeah.
it back. Let's go back to the review, but I will consider the bonus points idea for people to take notes.
If you,
Is that,
yeah,
okay,
but I'm saying you can edit your slides in the same way you post them.
interesting.
And then
Yeah.
you can just
Why did
repost
you
those
just
slides
not
with your
understand
edits
this?
so that people can
Oh,
see, these are the notes that you made with
got
it.
it.
'Cause for
All
the
right,
first-
guys, let's bring it back. You wanted to know the n log n solution.
Yes, let's-
So
Yeah.
what is the recursion? What is
So
happening?
what you're gonna do is you're gonna multiply the right side and the other side, then you delete the end of the primary.
Maybe, again, I feel like sometimes you guys are like trying to get all the way to the end of the
Yes.
answer. Whereas really, I would encourage you guys to like just kind of write out like just first step, second step, and then as far as you get, you will get partial credit. You don't have to get all the way to the end to get it correct. So what is like, again, for this recursive solution, what might be the next step that you would consider here? So reminding the hint that I said, either the entire subarray is on the left, or the
Calculate the values of the, I don't know.
of the
Two
yeah,
partitions.
of the two partitions. So you could say max left is equal to my solution. So I'm going to call myself my algorithm on the left side of the array. Okay, and again, because for recursion, because my problem is getting smaller, I am going to assume that this will return to me the answer for this array, which is, in this case, it's what?
Eight.
-8.
Eight, right? The
Negative eight.
maximum.
No, the way you circle, that's eight, negative eight.
No, so yeah, it would basically just say the negative number will create.
Yeah, so the answer is
So it is
actually
eight.
4 and 2, and in this case, it would be 8.
That's
Okay.
if, that's if.
If this was your array,
Because it would see that if you added the third one, it would become
Yes.
-8, so it would
And
just
then-
do the 2 before.
yes, and again, with recursion, you just, because the problem is getting smaller, you assume it works.
Okay.
And the reason it works is because eventually it gets to this base case. Okay, and it will for sure work for the base case. And then once it has those two answers for the base case, we are about to write what is the logic to combine them into a better answer, right? So again, then you might say, well, max right is solution on my right side. And again, because we are creating a smaller array, we are going to assume it works for this. And the answer here is what?
33.
32.
Yeah, so the answer here is 33. So max left is going to be 8. Max left is right is going to be 33. How do we, so given the answer to this half, now I want to know the answer for the entire array. How could I do that?
Wait, can we also have to do the crossover case too, though?
So there is a crossover case. So now we need to think about the crossover case because these do not handle the crossover case, right? It took care of if my answer was on this side, the answer would be 8, right? If my answer was on this, the answer would be 33. The only other possible case is that my answer somehow includes these two numbers, right? So if you know your answer is going to include these two numbers, how would you compute the maximum contiguous subarray?
The
Would
median.
you do,
Median.
you start from the center and then add one on this side and add left and right basically?
Perfect. Yes, that is exactly it. It's actually a little bit of code, so I'm not going to write it all out. It is a little bit of code. But what you would do is you would start with the 3 here, and then you would have a for loop, right? Starting at 3, or whatever. You might say like I equals 0 to n divided by 2, and you would say, let's call it right. It starts at a of n divided by 2 plus 1. And again, the plus 1 minus 1 won't be like, I wouldn't worry about it, but basically it's like, I'm still going to start at 3 and I'm going to say, 3 is a possible answer. So I would say max right starts at right. So that's a possible answer. And then I would do the check you guys have been doing this whole time, which is like if, and I guess this actually starts at 2, but I wouldn't worry about it. So right times equals a of n divided by 2 plus I. And again, you can write this in many different ways, but the idea is you look at 3 and then you say, well, it could be 3, or it could be 3 times 11, which is 33, or it could be 3 times 11 times -2, which is -66. And each time you compute this, you compare it to your current maximum, right? And that will give you, going this way, the maximum is 33, okay? Going this way, including the 3, right? So that's the key, that we definitely included 3. It'll give you 33. You do the same thing going this way, right? So again, writing that code is basically this for loop, but you repeat it again, right? So again, that running time is going to be what? Of doing this process, what's the running time?
Oh, that.
It'll be O of n, right? Because I look this way, 1, 1, 1, 1, and then I look this way, 1, 1, 1, 1, right? If you look this way, it'll actually start at -1. Then it'll say -2. Then it'll say, oh, this is actually interesting. I don't know if this works. Does this work?
I feel like it's doing the same thing.
Because
This is reverse order.
because 3, because what I want is I want this to get all the way to negative. actually one, oh, I actually need to do them. Oh, you need to like do them together from the center and then like move one and move one, move one, move one, move one. Okay, just pretend you wrote that. In the.
Just generalized outrage.
Yeah.
I can pretend
It's
all I
so much
want,
funnier.
probably not.
See what happens.
I would say if you didn't write this, oh man, I would be inclined to give you the full points. Is that hard? Okay, you can try to write.
It sounded
you-
hard to me, and that's just because you're confused about it. It's automatically harder for me.
So
So
take it off, take off the exam. Yep.
For me, I'm
Oh.
trying to
Yeah.
give you full point for the.
Absolutely not.
Yeah, full points for the
I
brute force.
completely-
I'm still trying
I
to.
So
know.
maybe
I would-
So I'm just kind
okay.
of trying to see what
Because I-
small points I can get.
Wait, but again, like here's, yeah, Leander.
What if instead of making the awkward work actually needed, what if the awkward work is extra for
I'm with that.
Okay, here's my question, right? At the end of the day, the points you get on the test don't actually matter,
Why not?
right?
Oh,
Because,
oh,
no. Oh, wait. Okay, yeah, actually, wait. Okay, so I could be misunderstanding. How does, let's say everybody in the class gets a 20 out of 100, right? Okay, let's say that. And then let's say at the end, I'm grading the class and I realize that everyone in the class is 20. So then I say, okay, everybody that got a 20, you get an A.
Nice.
How does that, like, why does the 20 matter to you?
Oh.
We don't know what everybody else is gonna
We
get.
have no, so we're worried about ourselves.
Yeah.
Oh, I see.
Because
Okay.
I could get a 20.
We don't know
Here's the
when we're
other
collectively
thing.
going to fail. We're under the impression half the class is gonna get 100 and half the class is
Yeah,
gonna get below
so-
50.
Oh.
So we don't know what's gonna happen.
I see.
Not
What
just
if
that.
I
Okay.
tell you after the midterm, what the aggregate and statistics are?
Doesn't Blackboard already do that?
Oh, it already does.
That is terrifyingly concerning sometimes in that.
Oh, does Blackboard do
Yeah,
that?
no,
Not just that.
Yeah.
So let's say we go back to the everybody got a 20. So
Yeah.
everybody that got a 20 got an A. At that point, I don't mean to be that guy because everybody likes getting A's. At that point, you're literally passing people for failing. So granted, you're doing the same. As long as you tried, you kind of got it. But if you do it like that to that extreme,
Right.
None of us
you're
know.
not.
Oh, yeah, I do
teaching.
agree. I
You're
do
just
agree
kinda- If
that-
it's to that extreme.
I do
you're not
agree
being
that like
taught.
if everybody,
I mean?
yeah, I would not want everyone to get a 20,
Yeah.
which is the
If
exam.
it's that.
But I'm
tragic.
also like, do I need to design the exam such that everyone that's going to get an A gets a 94 plus, right? Is that like, because that's actually kind of like, I expect more than half of the class to get like a good grade.
Yeah.
Right, so then I need to make a really easy exam, in a sense.
And none of
No?
us expect. to get
It's
that
not,
either.
it's
You're
not
overestimating us.
that. I
Oh.
think, at least from the way I understand it, if at the end of the day, if we went straight for the brute force, if we took every coding question and went straight for the brute force example, we'd probably get around a 70,
Every
right?
person will
At
get
least
about
for
70.
that, you would know they understand up to this level right here.
Yeah.
How can I then tailor how I'm teaching them for them to not only make it back to this level, but to go past that and understand it by the time they get to the final?
Right, so here's the thing, right? If I make, well, yeah, I guess I could make them bonus points, but I don't, yeah, I guess I think at the end of the day, it doesn't really,
Considering the
affect
brute force
you,
solution
right?
isn't what we're actually learning in class at the moment. We're learning there.
Mhm.
The brute force is definitely a part of there, but if that's as far as we can get, then I don't know.
okay, for this one, I may consider making this bonus, but I do think,
This is just kind of, you can do about 1,000 different things with this one.
okay, I am
Maybe
trying
that's
to make
a
sure
good
you guys
idea.
don't, yeah, what does Blackboard do?
It auto shows you the average and median now.
I got you.
That was
I got you.
terrifying.
Uh-huh, okay, but it is set up, okay, I will try to figure out
I've got no
Blackboard so
clue
you guys
why
can
it does
actually
that.
see more, yeah.
It does not do that for quizzes.
I was just wondering.
Yeah.
When you have like the max left, how do we? I actually forgot.
Right, so actually, to finish this, the final answer is you would say return the maximum of the left, the right,
Combined.
and the combined, which I forgot to mention
Which
how
would
to
be like the
calculate.
whole, max whole, I guess.
It's not the whole array, but it is, because you know that -1 and -3 have to be in your subarray, then in linear time, you can expand it piece by piece, such that it might not be like the entire array, but you will, like, let's say this -2 was here, and this -1 was like over here. It'll like expand to include -2, 3, and then 11, right? And then if this was 4, maybe like include 4 as well.
I'm actually just very lost now.
Yeah, this solution
Yeah.
makes zero sense to me, unfortunately, it's just a concept
So,
thing.
I mean, so this part of it is probably most of the points for the question. This rest part, like this part, is probably like 1 point or something.
I'm not sure how you like, you're comparing like what is greater and what's 9 are so.
Oh, we are taking the maximum at the end of the 3 numbers. So I just wrote max of 1, 2, 3 things, but that in a sense is like whichever one is the biggest, it takes that.
Okay.
Yeah, Serena?
So doesn't that crossover case end up being just as bad as the brute force? Because you have to check like every single combination, just including the.
Well, it's not as bad because you only have to do it once. So it's like if I told you that my array had to start at 4, then you don't have to check like an array that starts at -1 or at 2, right? You know it starts at 4, so you, at worst, you will look at the entire array. But that is, I think, the worst you can do, right? So, yeah.
Isn't the combined just, like, what we did it before, but instead of starting at the beginning, we're starting at the middle, moving out?
Yes.
Yeah,
That-
the rest is.
It's
No,
so-
no, because if you start, if you know 4 is going to be in your answer, let's say I told you that the first element is in the answer, then you can just write a for loop to like iterate over and then keep track of that. Like what you, the only question is not where do I start, it's where do I end? Because I already told you where to start, right? So you could just be like, well, do I end at 1? And check like, what is that? That's -4? Maybe, I don't know. Do I end at 2? That's -8? Okay, definitely not. I might end at 1, right? But definitely not this one. Do I end here? Again, this is negative. Do I end here? That's negative. Do I end here? That's negative. You actually end up getting that you end, I guess you don't include -1, you end at just 4.
Wouldn't that just make the whole thing like all of them problems? You look at
Yes,
all of
so,
them, and then
yeah.
making all that problems.
Yes, so no. So this, this part is O of n. And by the master theorem, that means this recurrence is 2 times t of n divided by 2 plus O of n, which is n log n, which is faster than our n squared. So that we were trying to get a faster solution than n squared.
Yeah.
There is also a solution to this that is just n, but we're not gonna cover that one. Is it easier to implement? Yes, but it is, well, it's easier to implement, but I don't know that it's easier to come up with. It's for, well, I think I'm sticking around till 5:30, but it is 4:59. Okay, so, wait, conclusion and discussion for the test. People feel, okay, what if the average was like an 80? That's like,
If the average is in, honestly, I think it's sort of like debating what gets
What?
bonus points. I think it's better for the reworks, like giving students the actual chance to go in and ask, okay, how do I go farther than this, or where did I make mistakes?
yeah.
Allowing the reworks and chance to gain bonus points there is
Yeah.
probably a lot better than
Probably.
debating it. with
Yeah,
the
I think
points.
that's, so that was the, so last time I had the review session, I originally was not gonna offer midterm corrections, but then it was suggested, no, I am. It was suggested I should offer midterm corrections.
Especially if like the method you're grading is like brute force gets you about a 70, rework lets you.
Okay,
figure out the
To be
higher-
fair, the brute force gives you 7 out of 10 points out of 3 problems in
Yeah.
the exam.
But
Okay,
more just at the.
which is, so that means at most you lose 3, you lose 9 points if you don't get any of the brute force. If you get the rest of the exam, which is more like the quizzes,
But even
then,
if it's, if it's like 100, well.
and
still,
it's out
but
of,
still-
it's out of 89 points now.
But still, though. But yeah. Allowing just.
It is not an A for sure,
Yeah.
but.
Allowing the correction.
So that's why I was asking, like, is the best design for an exam from the student point of view, one where you,
Anything
If you
that
get an
allows you to go
A,
back
then
to
you're like, I
zero.
will get an A at the end of the semester or something like
I
that.
think
Anyway.
there's a part of me that just wants to like pass the exam, but there's also another part that wants to understand. the
Understand
concept.
why.
Yeah.
So
Yeah.
that's why like the corrections are cool,
Yeah.
because if
Yeah.
like we can go back and talk to you and see like where we went wrong
Yeah.
and benefit from it as well. after-
Yeah, okay. Yeah,
That's like the same thing that I was
Any
talking to
exam
you
style
about
that-
one-on-one
that
yesterday.
has corrections.
Like if I know, like, from a, even I guess from like a test anxiety standpoint,
Right.
if I know how to do the brute force of this problem, I know I can get at least like half to 3/4 of the points. I know I'm gonna start by writing that down.
Yeah.
So that I know that I'm gonna get those points. And
Yeah.
then if I can attempt to figure out how to get past that, I'm gonna try.
Did somebody take a picture of this?
Not that
I wrote
piece.
it down. Well,
Okay, write it
Hold
down.
on.
That's great. Share that with me to my email. All right, conclusion, guys, don't freak out about the exam, even if it's a little hard. It will be mostly. I do think there's a lot, okay, you guys maybe you guys disagree with me, but I personally feel there is value in at least showing some of the students in the class that are like doing very well, that there is a lot more to be learned. But I guess maybe the midterm grade is not, it's not the best. So if I, wait, actually, but that is a good question. I don't want to affect your guys' scholarships or stuff. When do they?
Allowing recorrections usually should fix that, because
Okay,
usually they'll take, I don't know how EdCat does them, but usually any outside scholarships will ask for a midterm report when you apply. And after spring break, there's usually like a 2 to 3 week gap.
where does the report like come from, or who?
Usually just ask for your transcript and they send it down.
Yeah.
Oh, did it, when I submit the grade on Gradescope, does that get reflected on, or sorry, on Blackboard,
Yeah.
it gets reflected on your transcript?
Basically.
Because it goes as our midterm grade and basically what they
Whatever
do.
your average is for the class.
Yeah,
will be
during
what
your
is
midterm.
reported. Like not necessarily like the midterm, like test
If
grade,
I
but
have
your
an A-
midterm overall grade.
Not the actual test.
So
If
like
I-
say you flunked that, but like another section was like a little bit higher, and say you got like a D on the test, but like.
If I have a
Maybe
20 in the
an A and a
midterm and I have,
different
and it puts me at a 70 in the class, my transcript's gonna show that I have 70.
Right.
Oh.
Yeah.
But for teachers that, only have 2 tests, which are the midterm and the finals, and homework are worth 10%.
Right. It's way.
You're not
But
gonna
like,
please don't
it's
do
not
that.
like they'll take,
Please.
like, say if you like end up failing the midterm, it's not like they'll send like an F. They'll send whatever it is with the average. Now, if you-
Okay, that's good to know. I need to
That
figure,
makes
okay,
sense.
so then
Yeah.
actually, when I put the grades in Blackboard, there is like a immediate effect. It's not just the final grades when I assign you letter grades that matter. It's like,
As soon as it's in there. you have
It's,
it.
yeah, it's like,
Really?
that's your grade, like. right
Okay.
there, right there.
maybe I should track the grades in a spreadsheet instead. And then just like,
The grade in Blackboard is not correct.
yeah,
Because it
Yeah.
doesn't use the, I have like a 200.
yeah, because
Right,
how am I?
killing
I
it
had the
up.
exact same thing and it was
Yeah, yeah.
hilarious.
Yeah, well, I
900
need to
times
fix
six.
that, but then 2, how? Because I want to be able to drop certain grades. Okay, I thought I just submitted whatever letter grade I wanted at the end of the semester.
Basically.
You do.
Yeah.
Oh, I do. Oh,
yeah.
That's you, and it
You-
also
you
will
can.
just take that.
But it's just that a good majority of the semester is probably just gonna reflect like incorrectly for us.
So if
Ah.
we pull a transcript before you submit in a letter grade for us, it's whatever the Blackboard says. If you already submit the letter grade, it just spits out whatever the letter grade is.
Whatever the letter
Yeah.
grade is.
It's
Okay.
weird.
Okay, I will
None of
mess
us
with
like
Blackboard a
this.
little more to see if I can, because the whole policy is, okay, lowest 2 homework grades get dropped, lowest quizzes get dropped, and then lowest 4 quizzes, I think. And then,
I'm killing it up. I'm definitely gonna be killing it up at the end of the semester.
I don't know.
Thank God,
Okay,
'cause I did
anyway,
not do well
so,
on that last one with
again, you
assignment.
guys should assume that I don't really know that much, because nobody tells me these
You've
things.
been here for like,
You're
what,
welcome.
two,
Yeah.
2 months? You're fine.
Yeah.
You're
But,
very much fine.
I had a
We've been
separate
here 2
question.
years. and
Yeah,
we don't
so,
know what's going on.
yeah.
You said that, and I asked
Yeah.
asked you this yesterday,
Yeah.
for the other extra credit on the midterm exam,
Yes.
we have to have submitted all homeworks
Ah,
or
yes.
or
So-
homework corrections and all quizzes.
If you guys want to know the bonus points on the midterm, which is
Yes.
up to 10 points.
Yeah,
There is
that's
one
extra.
question that I don't think anyone's gonna get the bonus points on, but I put it on there just because I want to see, like, I feel like there's like a few students, there's like 1 or
Is it
2
like
students
your
in the
name?
class that I think are like more advanced than they should be. But anyway, Then the other one, there's 5 bonus points. One question is, did you have fun taking the exam?
No.
You'll get a question.
Right now.
It's an exam.
And don't be hurt when I put no on the exam.
The other question is, did you learn anything new? And then the last question is, did you submit all your homework and quizzes from 0 to 5 in quiz 1 through 6?
Okay.
So that is how,
How are we supposed to resubmit quizzes?
I think they're all open now. Just resubmit them.
Okay.
Yeah,
like
because every
on
time you
the
submit,
course
it takes
website?
on the Google Forms. I think I set up the quizzes such that every time you submit, it records a new submission. So I will know you submitted after because it takes your timestamp. So due date for homework corrections is until the end of the semester for all of them, just FYI.
Oh, is it like, it's some off each day?
Yes, so the way that works is, well, yeah, no, it, okay, yeah. So it's 10% off each day that it's late, up to 5 days, at which point it disappears from Gradescope. And in order to submit either the homework or your corrections, you have to email them to me. And at that point, your corrections can only get you up to half of the points back, right? So, yeah. However, if you submit your homework on time, and then you did poorly, let's say, you can submit corrections anytime in the future before final grades are submitted to get up to all of your points back.
Oh, wow.
Okay.
Again, at the end of the day, it's like mostly for you guys to learn. But okay, to submit the correct, so those corrections, you have to email me. You have to email them to me, both the code and the written. I will look at them, so it won't be cheating. So I'll be looking at them, and then I will schedule 10 minutes to talk with you over to discuss the solutions. Yeah. So.
So for the test, will there be any coding questions or pseudocode questions on hashing or graphs? We got to practice that in the homework.
Not on hashing. There may be reading pseudocode on graphs, but I don't believe. Do you define trees as graphs? Like the first question we did, like would you consider that? Okay, well there may be questions like that, but not.
Graphs like the crazy line.
Like the ones we just learned, like with.
Like
learned
DFS.
last
Okay,
year.
yeah. So strongly connected components, no. DFS and BFS are on the exam, but they are not pseudocode questions. They're like understand, like trying to test whether you understand how it works.
Did you have another
I
question?
have a question about
Yeah.
some of the terminology, like weighted graphs, and I think there was like 2 other
Yeah.
terms that I wasn't
Yeah.
able to read over. I forgot.
Okay.
Really quickly before we do the last ones, the solution you had on the board at the end, that was the ON log n solution.
Yes. Oh,
And that was merge, was that merge or quick or conquer and divide?
sorry, that was what or?
Was that
that
merge
merge, sort,
or
or
conquer and divide? Divide and conquer. My mistake.
Divide and conquer. Merge sort is an example of a divide and conquer algorithm.
And also, are there gonna be strongly connected components on the midterm? Just a little iffy on that as well.
Strongly connected. Didn't we? So, we covered a little bit of it last Friday. Unlikely.
Okay.
Yeah.
So yeah, just like it was like weighted graphs.
Weighted graphs we actually just covered recently, so those are definitely not on the midterm. Like we covered them like Monday, I think.
Can we just go over graphs, like?
Yeah.
Like what we need to know for the.
I mean, I think the practice questions on the midterm at the end are pretty good reflection of what you will be asked to do. So for example, 24, 25, let's say 26. That's probably like one of the harder questions about graphs you may be asked. So we can do that one, right? So the graph is like F, E, there's G here, and this goes to C here. Here's E, here's F. What is that? BA. B. Okay, so for example, one question that you may get asked. So let's say you're given this graph. What is the matrix representation of this graph? Matrix representation, anyone?
No.
Is it source, is source and destination, like source of destination on the side, or is it the other way?
I'll give you credit either way.
Okay. So I guess you can start off by listing A, B, C, like all the way, A through G.
All right, so A, B, C, D, E, F. Wow, there's so many nodes. G, okay. Then A, B, C, D, E, F, G. Okay, which of these do you want to be the source and which to be the destination?
I'll do
I guess
F
the
be
top
the
one.
source and A be the destination.
So that this is
Like you can have F be the source and then, oh yes, so destination, source.
okay. All right, so this is a matrix. So if we wanted to represent this graph as a matrix, right? The first thing you do is for each column and for each row, you label it with the corresponding node. So these nodes are letters. If you're given nodes that are numbers, it might be more natural to label them as like 0, 1, 2, 3, 4, 5, right? Okay. Then you have to say one of these is my source, one is my destination. So you have to define that, right? So then what would this look like? Then you would look at each edge and you say, well, there's an edge from F to E, right? So from F to E, there should be a 1, right? And then you would repeat that for the rest of the edges. And then you would put zeros everywhere else, right? So this is like probably too big of a graph. I probably wouldn't ask you about this because this one's kind of like a really, this would just take a long time to do, but you might expect like, you know, let's pretend we're just looking at these 4, right? F, E, C, G, F, E, C, G, F, E, C, G, right? So, yeah, but we can fill this one out, right? So F to E has a 1. E to C has a 1. So E to C has a 1. F to C, yeah, F to C as well. That's a 1.
G to C has a 1.
Sorry, what?
G to C has a 1.
G to C also has a 1, right? And then C has nothing. So that's it. 1, 2. So you can also count. You have 1, 2, 3, 4 edges. So you should have 1, 2, 3, 4 ones. And then that means everything else is just zeros. And you would say that is my matrix representation of this graph, right? The other way would be adjacency list, right? So yeah, what would be the adjacency list representation of this graph? Yeah, you want to give it a shot? Yeah.
If you write it out like C, E, F, G.
Yeah, so we might do like C, E, F, G. So again, like in real life, these probably map to numbers, but you can imagine you have an array that corresponds to each node, C, E, F, G.
C doesn't go to.
C has nothing in it because it has no neighbors.
E goes to C.
E has a linked list that then has C in it.
That goes to E and C, so we just do
1 to E, and it also goes to C, so you include that here. And then G goes to C. So this would be the adjacency list representation of this graph. Okay. And this is the matrix representation. So you should expect a question, probably some related to that on the exam.
Like,
yeah.
What is acyclic? Did we talk about that?
Yeah.
Acyclic or
Acyclic. It's on the project.
acyclic? We did talk about it. We talked about it a few times. I think I asked you what you thought it meant.
Is it a graph without a cycle?
Yeah. So acyclic, so the A just means not cyclic. So it's a graph without a cycle.
So
And yeah.
So is it 3? Another word for 3?
It's a what?
Another word for 3.
Well, a tree has to be a connected graph without a cycle. But yes, a tree is a connected graph with no cycles. That's a tree. You can have non-connected graphs that don't have cycles.
So this graph would not be connected, right?
Yeah, this, so this graph is,
Because the G isn't, it's like,
There's no cycle.
there's definitely no cycle in it,
Right.
I would say. And then is this connected or not? I would say, yeah, because it is not strongly connected, that's for sure. But I do think you would say this is connected.
most of the nodes are connected in some.
Because there exists an edge between, there are no nodes that are there are no nodes that have no edges to or from them.
Another.
Yeah,
Okay.
to another node. Yeah.
So if there was nothing like going from G.
Yeah, so if this was here, this would be disconnected.
Okay.
Right.
So as long as there's a connection.
As long as there's a connection, it is connected. But you are right, it is not strongly connected because there's no way to get, for example, from C to G. So there's no path going back.
Professor?
Yeah.
I think I'm having a lot of trouble with like putting it in topological. Like,
Yes, so being able to topologic a sort of graph is something you should be able to do with, let's say, a simple example like this. So so again, you don't necessarily have to run the algorithm because it's not a large graph, but what would be a topological sorting of this graph?
F, G, E, C.
F, G, E, C, okay, that's valid. What is another valid topological sorting? There are many.
G, F.
Yeah, you can do G, F, E, C. Is there another one? Yeah, you can do F, E, C, then G.
You can't do C.
Oh, you can't do
Yeah, you can't
C,
do C.
right? You have to do F, E, G, C. Yeah. So if you guys can do that with like a graph, let's say 4 or 5 nodes, that is topological sorting. Let's see, what else does this ask? So undirected, you guys should know what undirected means. It's just not directed, acyclic. Oh, I guess weighted is on the practice, but we didn't cover it on. Weighted just means like each edge has a number associated with it. So like if I had 4, 2, 1, 3 or
Oh, that's
something,
used to count many.
those are called weighted graphs because each edge has a weight.
And it's undirected because there's not, I mean,
This
this
one's
one's directed.
this
right?
one's directed, yeah. And then undirected would be one
But it doesn't
where,
have arrows. right?
yeah, you would drop the arrows because it means that F to C and C to G both exist.
Okay.
Will C be last because the arrows pointing at?
Yeah, C is always last. In all sorting, C has to be last. Yes, you are right. That also means that C has the largest finishing time for any DFS. Cool, okay. Yeah.
You have.
No, I'm just.
So that, yeah, for graphs, I think, yeah. Yeah, so you want to know if it has cycles, you have adjacency list, adjacency matrix, okay.
So we're starting at F because nothing is going on. You can start at G. Then you can C is the last one.
So you're literally just going into what has the most least arrows?
It's not necessarily most to least arrows, but the only definition is that whenever you put a node down, like when you write down a node in the list, anything that is going into that node has to have appeared before it. So that's why, like, if you write C down, you have to have E, F, and G all before it in some way, right? So that's why C is always last in this case.
So if we expand it, it's all, it wouldn't matter where you put the grid.
We don't have to do the bigger graphs, do we?
Huh?
We don't have to do anything bigger than 4.
I forget how big the graph is, but it's not gonna be too big, because I don't want you guys to spend like a ton of time writing it out, but it might be like 5, maybe 4 or 5, probably 4. No, it's not gonna be, yeah, I mean, even this one that was I think this is too big. 1, 2, 3, 4, 5. This is 6, so it's probably gonna be 4 or 5 or something.
My test is going to be multicolored. I apologize in advance.
Yeah, and then, yeah, try to change some of the questions to bonus points, I guess. Except I already printed the midterms. So maybe I'll do it as a correction that they are now bonus points. Yeah, these questions are bonus. Okay, that's fine. Yeah, I'll do that. Oh yeah, you guys also have cheat sheets, right? Great. And then I need to fix Blackboard, it sounds like, because people use it for scholarships or something. How can I see like,
More just ensure you're good. More just ensure that the letter grades are accurate for your overall average.
I hate Blackboard.
Everyone hates Blackboard.
Yeah, it's just annoying, it's just like the fact that it like reflects your like exact grade, so then you have to send it in and like potentially the grade isn't good.
Yeah. Yeah, I'll try to figure out the grade center. I just literally what we do is I have a spreadsheet where I actually keep track of your grades, and then we just put them in a grade scope because I thought, or sorry, in Blackboard, then I would at least, it's a way to inform you guys what the grades are, but there's more, it looks like there's more settings. You can actually specify the weights for different things, and then.
Yeah, there's like don't like to spend your time doing, so we haven't.
Got it. Okay, I will, I'll look into it and probably fix it, at least before your midterm grades go in. Yeah, we have 8 minutes, so any other questions from folks?
If we focus
Can we do
on
the
one.
average herd size one?
Average herd size one, okay,
Number 29.
29. Oh my God, where is it?
No, it's
Yeah, no,
Right here.
It just
I mean, I
appears
can-
forever.
Oh, I got it, but thank you, I appreciate it. Okay, it says, so did you guys read the problem? Average herd size on the practice. All right, guys, come back. So who did the last one on the practice midterm?
Yep.
Who did it and wants to explain it? No? Okay, so you have wildlife scientists observe elephants in the national park. Although the elephant herds may rarely be seen all together, so it's hard to see all the elephants at once. The scientists want to observe the average herd size. So they want to understand, on average, how big are the herds that elephants belong to, okay? Right, does that make sense so far? A big part of an exam is understanding the question, I guess. So they record all elephant interactions they observe over 3 months. So does somebody want to tell me what that means?
They record each time that elephants get together over 3 months.
Yeah.
Is it each time that elephants get together, or each time that herd of elephants gets together?
Yeah, so it is each time 2 individual elephants interact that gets recorded.
Okay.
Okay, yeah, so it does say, okay, the scientists can uniquely identify each elephant. So they tag them, let's say, so they know the unique number for each elephant. Elephants will only ever interact with other elephants in the same herd. Okay, so it is known that if 2 elephants interact, they are in the same herd. And elephants can only belong to one herd. So they never belong to other herds. Now, the first question is, in order to solve the problem, which is I want to find the average herd size, we can represent this as a graph. What are the nodes and what are the edges?
So the nodes are the elephants. and the interaction.
The nodes are the elephants and the
And the
interactions are the
interactions
edges, right?
Yeah.
Yeah. That makes sense? Okay. Oh, okay, cool. So which graph properties apply to this graph? Select all that apply.
Undirected.
It's undirected.
Yeah.
Isn't it also acyclic?
Could be
It could be
cyclic.
cyclic, never mind. So I know undirected because you can
Yeah,
go back and forth between the elephants.
Could be weighted too.
could be weighted.
There's a number of interactions.
Like the number of times you want to keep track of the number of times elephants interact. It's definitely undirected. I would say for the weighted, because you're trying to compute. So again, the goal is to compute the average herd size. The number of times they interact doesn't matter. You just need to know whether they interacted or not, because that defines whether they belong to a certain herd, right? Cool. So the last question, how would you solve this problem leveraging graph algorithms we've covered? Which algorithm would you use in words and how you would produce the average herd size among all the observed elephants? Yeah, so now we have this graph where the nodes are elephants and edges are anytime 2 elephants interact with each other, an edge is created. And we are not tracking how many times. We could, but we're not. What we want to answer is on average, how big are the herds? So. Yeah.
You use breakfast on like a specific note and then go down the list and see which to find all of those. And then once you're done with the graph, you go back to the top, do it in another spot and have it over and over again to try and figure out how.
Yeah. Serena?
I think you'd only need to do depth first search actually, because if they don't interact, they won't be interconnected back. So like you can kind of treat them as separate graphs. So you do depth first search and then you count every time you interact with a node. And then like you just, after you go through the whole thing, you just go to a new elephant basically, see all this.
Okay. Actually, both solutions are correct. So one way to think about it is it's asking you what is the average size of the herd, which you would say, well, if I'm working backwards from what you want, if I want to calculate the average size of the herd, I need to know two things, right? What are the two things when I want to calculate the average? You need to know how many herds there are, so number of herds.
How many elephants?
And then you need to know how many elephants total. Right? So if I have 100 elephants, and there are 5 herds, then on average, there are 20 elephants per herd. Okay, got it. So then you could say, well, that's what I want. How do I compute the total number of elephants?
Don't you already have that?
1, you could already have it. 2, let's say I don't have it, but I have the graph of all the elephants.
You can just count.
Yeah.
Add up all the groups together, so like you find like 4 of one group and then 5 in the other, you can add them together.
Yeah, so you can run DFS to explore the entire graph or something, or you can, like, if you have a matrix representation, you can count all the ones, right? And that, well, that tells you the number of edges. You count how big is the matrix, because that's n. If you have an adjacency list, you would count how big this is. Either way, this would be like either BFS or DFS can keep track of every time I visit the node, I increase the count by 1, right? So that gives me the total number of elephants. How do I know how many herds I have? They don't have to be strongly connected.
How many times DFS has to reset basically?
Yeah, how many times DFS resets? So remember, DFS discovers connected components. So if I start at a node, it will discover the entire herd for that elephant. Because if I can get to you, then you are part of my herd and DFS will get to you. So the only thing you need to track is how many times the DFS restart, right? So that will tell you the number of herds, right? So, and you can also use BFS. So again, BFS or DFS for both of these. And then the only thing that this question is really testing is, you know that DFS and BFS can be used to count all the nodes, and you know that every time it restarts, that corresponds to a herd. That makes sense? Cool. I can stay a little longer if anybody wants to, but we are 5:29. One more minute. Any other questions?
If we had to focus on one thing over any other concept, like a series of concepts, what would you say?
Whatever's in the practice midterm will probably get you. Again, you will never, any of the questions we covered today and any of the questions go in the practice midterm and any of the questions on the homework and any of the questions on the quiz, you will never see them again. But yeah, I'm sorry, I don't know. But you might see very similar questions that have the same concepts, okay? But yeah, it's, I don't know, maybe next time I do the class, I'll do, I've heard, yeah, I don't know, maybe I'll next, yeah. I was recommended that what I could do is I could have like just repeat questions of homework or something, just to make sure you guys knew it on your own, which I feel is like a very low bar for students, but it's also, I don't know, I guess like kind of depends like.
I had, okay. The fact, I will say that does help.
Yeah.
Yeah.
I think I definitely agree that it should be a different question. But again, like maybe like for the like practice midterm, since we don't know how the midterm is, like, I mean, in a sense, you kind of want it to be similar. So
Yeah, the practice midterm is, I would say, very, very similar to the majority of the midterm.
it's kind of like cheating the way if we already know what the
Well,
question is.
I think
There
it's
is
like,
a-
it's sort of okay, but it just tests something different to me. So like that's testing like how well can you prepare and how well can you learn this specific thing? Whereas I'm trying to test like how well, how well did you learn the concepts that lead you to finding this answer, right?
I will say for that, if you did want to go the use old homeworks problems like route,
Yeah.
what you can do is you can take homeworks.
All right,
from,
folks on Zoom, I'm gonna drop off.
You can take the homeworks from like homework 1